right, here we have an area maximizing problem. And we got some fence, and we want to make a barn. And the barn is going to border a river. So the barn is to be formed enclosing a rectangular fenced area bordering the river. So let me draw the river. That's good enough. You only have 240 yards of fence to enclose the barn. So that's going to be the barn. Okay? So the question is, what are the dimensions of the barn with the greatest possible area, given, of course, that we only have 240 yards of fence to enclose the barn. So here's the fence, right? Like the red lines here will be the fence. And note that the side bordering the river, so this one, does not need to be fenced. So we can basically save some fence on this side bordering the river. So let me make a slightly more believable river. Some fish. And we can save some fence to make basically a bigger barn. So the question is, what are the dimensions of the barn with the greatest possible area? So let's get started. It's a rectangular barn. I'm just going to call this here X, the length of this side of the barn. And I will call this, the length of this side, just Y. Of course, this side is also going to measure Y because the barn has a rectangular shape. No, we know that. We only have 240 yards of fence. So if I add up all these values, so the Y plus the Y plus the X, we only have 240 yards of fence. So Y plus Y is 2Y plus X is 240. And basically that's just a little perimeter here, right? And now note that the area of the barn, because it's rectangular, is just going to be length times width, which in this case is just X times Y. Note that a big common mistake is to multiply it by 2Y, but remember that the area of a rectangle is just length times width. So X times 1Y. That's it. So now we have X times Y, but I want to get rid of either the X or the Y. And how can I do that? Well, I know that 2Y plus X is equal to 240 because we only have 240 yards of fence. So I'm going to isolate X here. How can I do that? I'm just going to subtract 2Y from both sides. Those go away. X is equal then to negative 2Y plus 240. So I can take this and place it right here. So negative 2Y plus 240 times Y is the area. Now I can distribute the Y. So I get A equals negative 2Y times Y is negative 2Y squared. 240 times Y is 240Y. Okay, now we want to maximize the area. And to do that, I'm going to complete the square. Hope you're familiar with that concept. And why do we want to do this? Well, because once we complete the square for this, we can basically find the vertex of this parabola that relates the area and the Y. That way, we're going to find the maximum area and the value of Y that's going to make that happen. So let me factor out a negative 2 here. So I'm going to get negative 2Y squared divided by negative 2 is just Y squared. 240Y divided by negative 2 is negative 120Y. Okay? Great. So now to complete the square, I need to take this number, the negative 120. I need to divide it by 2 and square it. Negative 120 divided by 2 is negative 60. Negative 60 squared is 3,600. And I also need to take away 3,600 to just balance the equation. It ran out of room there, but that's okay, I think. So let me show that over here, actually. So I have 3600 minus 3600. But I'm going to have to take this outside of the parentheses. And to do that, I'm going to need to multiply by the -2. -2 is really the bouncer of the nightclub. The nightclub being the parentheses. God, that's a silly thing to say, but it's okay. Negative 3600 times -2 is just 7200, comes outside. So we have area equals y squared minus 120y plus 3600 plus 7200. We just needed to multiply them. And now I can actually factor this. That's the reason why we added the 3600. This will factor into y minus 60 squared. If you're skeptical, just distribute this. Just go y minus 60 times y minus 60. It's going to expand into this. Plus the 7200, of course. Great. Okay, now the question's done. Why is that? We want to know the dimensions of the barn. Y equals 60. Note that we just need to flip the signal here. Y equals 60 is the value of y that's actually going to maximize the area of the barn. So y should be 60 yards. But we want to know, and I'm going to explain that more in detail a little bit later, what are the dimensions of the barn? Well, we also want to know x. I don't know what x is. I can just plug in the 60 right here for y. -2 times 60 is -120, plus 240 is 120. So x is 120 yards. So the area of the barn is actually just going to be 60 yards times 120 yards. So 7,200 yards squared, or squared yards, I guess. I'm not sure. And why does this happen? Why is y being 60 what's going to maximize the area? Because look at this. I'm just going to draw, don't have too much room. But if we basically maximize the area, and that's the area, and those are the values of y, if I pick 60 for y, that's going to be the vertex here. The highest possible area would be 7,200. If I pick 61 for y, we're going to have a smaller area, 62. Any other value other than 60 for y will give us a smaller area for the barn. So that is what we wanted, 7,200 squared yards of barn. Voila, so the dimensions are 60 yards by 120 yards. And we're done.